everyone, welcome to Harsh IT Lab. Harsh Verma this side. And today we are again here to complete our series over the Network Warrior book, and the topic for the day is tunnel. For those who don't know, we are actually going through the book Network Warrior, and here it is. So this is the book Network Warrior, Everything You Need to Know That Was Not on CCNA by Gary Donahoe. Actually, this book does not go into very detail about the networking concepts or terms, but focuses on the practical lessons that you need to know in order to serve the industry. So today we are going to study tunnel, particularly GRE tunnel and many types of it. So without any further delay, let's SSH into my smartphone on which I used to take notes and go to terminal, and this is it. So that I've created, and the notes only contains the thing that I feels is a must to share. So let's go to today's topic, which is actually we have been through all these topics that I'm skipping. You can watch the previous video for the same. We have covered OSPF, BGP, slide of BGP, redistribution was about the last video. And now, today, the topic is about tunnels. So tunnel is a kind of formation that we create between two routers, and it means that when local device can connect with remote device as if the remote device is local as well. So tunnel is a kind of virtual interface that establishes itself using some help of protocols that two remote devices feels like that they are on same network. So what advantage does it comes with? For example, there is no need to forward some specific ports. Once a tunnel is created, basically the devices are on the local network and they will communicate as if they are in a local area network LAN. So every port, every services is exposed intentionally unless we are blocking it on another level using firewall. Okay. So tunnels are a logical link and relies on the route that are already in place. So we will also look what tunnel consists of. We will look at demo configuration that is shared in the book. And tunnels are such a complex topic that I believe it is much better to understand with the help of demo how to actually establish a tunnel, what are its requirement. Okay, so we are soon going to see that also. Okay, this setting up the loopback interface as the target of the tunnel end is the best practice. So it's talking about the best tunnel practice, tunnel creation practice, and setting up the loopback interface. For those don't know what's a loopback interface is, it is a virtual interface assigned to every devices. So it can just test its connectivity. So we can assign an IP address. It does not necessarily have to be the loopback IP address. A loopback interface and a loopback IP address is a two different thing. And actually, so over here, that loopback interfaces and loopback IP addresses are two different things because the loopback interface can have a valid IP address. It may be a public IP address or a private IP address rather than only the loopback IP address which starts from 127 dot something something something. Okay, exactly 127.0.0, and the last subnet may be anything. So actually we do got 254 loopback addresses, concluding 127.0.0.0 is the network address, and 127.0.0 to 255 will be its broadcast address. So there's 254 addresses usable as a loopback address. So do not be confused in loopback IP address and loopback interface. Okay. Now, the tunnels suffer from the software-based processing on the device. Hence, it should not be the most desirable path by default. Okay, because tunnels are used as a software, because it's a creation of protocol, the protocol makes it looks like that it is a native route, but it is not. So the protocols could not defy the actual physics because we are not using any physical direct connectivity between two routers. So it should not be used as the most desirable path for the connectivity. It should be used like a link between applications or a side to side link, that if we want to change some configurations over there, but not for the main transient path for data transfer. We can use it for encryption because company uses it for encryption, but it's a secondary kind of thing, not the primary. Okay, so now we will study the types of tunnel, which is mostly two or three types. First is GRE tunnel, which stands for Generic Routing Encapsulation Tunnel. By default, it does not offer encryption, but it offers the advantage of forwarding the multicast and broadcast traffic. So these are the GRE advantage. Then second is VPN, which also comes in multiple different types. There may be point-to-point VPN or a remote access VPN or site-to-site VPN, which is also the point-to-point VPN. Okay. VPN does is encrypt all the information, but it does not have capability of forwarding multicast and broadcast traffic. So what we used to do is to establish a VPN and GRE tunnels simultaneously in order to get an advantage of both. But what we get in return is the latency, because tunnels are just a latency field because it's a software defined something. Hence, it should not be used as a primary, and we have already have a discussion about it. Also comes as a point-to-point VPN, which is between two remote servers or routers, and there's a remote access VPN which we use to install in our laptops, mobile applications. For example, you have seen the advertisements of Surfshark VPN, Proton VPN, private access VPN, etc. These are all single users SSL VPN, which comes under the remote access VPN. And finally, SSH, which stands for Secure Shell. Actually, the technology lying behind the SSH is a kind of VPN like technology, because it is able to forward the specific ports from one server to another. It's not a primary method of VPN, but I have heard in the industry that some people uses the SSH in order to access its remote devices as well as all the other devices in the same network. So SSH can also be used as a VPN. Please make sure to Google if you want to learn to detail. Actually, I have made a note regarding the SSH and its usage as a VPN, but we will discuss that in future video because it's a hell of a topic on its own. Okay. Uh, So we are seeing that misconfigurations in GRE tunnel may lead to recursive route problem. Recursive route problem is itself a problem in which suppose one link is dependent on the establishment of link. So it's a recursion because something has to exist in order to exist. So it's create a loop and the tunnel may flip flop. So before understanding the recursive route problem, let's look at my another simple basic configuration of how a GRE tunnels work in order to better understand its misconfiguration. So that should be our first priority. So let me jump to that. So in Tmux, once again, so I have to press Control B and then N, which jumps to the GRE tunnel configuration demo. So suppose we are establishing a tunnel from the router A to router D, and there are two additional routers in hop, router B or router C. Because we are those two routers are not part of our organization, we cannot have a communication or have a change in configuration is those two. So what we can do to establish a local area network type something, which is tunnel from router A to router D, we will use a GRE tunnel. So a GRE tunnel requires a loopback interface, an IP over loopback interface. So I request you to note down the requirements. So I'm repeating once again. A GRE tunnels requires a loopback interface, a IP over loopback interface, a physical connectivity medium. For example, here we are using fast Ethernet 0, which is FS 0 over 0, and a IP which is able to connect from the router A to router D over the fast Ethernet. Then a logical interface, which is a tunnel interface, and we name that interface tunnel 0. Then we require an IP over that tunnel interface. And finally, a simple IP static route that defines that in order to reach the loopback as a target of to the another router D, we use that physical interface IP. So basically, it covers these 5 or 6 requirements. So let's go to router D and we will require the same, and it will help us to repeat often the repetition, and repetition helps us to remember things. Okay. So in router D, we can see that loopback interface is a logical interface that is also present on the router D as well as on router A. We will require an IP address. Here we are using the private 10 dot series IP range on a loopback interface. The IP is 10, 200, 200, 200. Okay. For the router A, we were using 10.100.100.100. Okay. Now for the fast Ethernet interface for the actual connectivity, we 192.168.1.2. On the router A, we were using 192.168.1.1. Okay. And we are just turning on the interface because by default on a router, the interfaces are in shutdown state. So we have to issue the no shut command in order to bring the interface up. Finally, we are creating a logical interface. Because the tunnel interface does not exist on a router by default, we have to actually enable it by issuing the command interface tunnel 0. It will bring up a tunnel interface. We can, whatever we want, we can name the interface. For example, the tunnel interface 10, tunnel interface 1, 5, 6, whatever that you want. IP address to the tunnel itself, we will set the tunnel source from the loopback 0. So it will establish a tunnel between our loopback to others loopback, and we will the router A loopback will be reachable using the IP address of the physical port, which is fast Ethernet 0 over 0. And that's it, the basic requirement of tunnel. And so if you boil down all the minute details, you will find that a tunnel requires a physical interface for the actual connectivity, a static route to tell how to actual connectivity establishes between the tunnel, because tunnels also has an IP address by this here, that in order to reach the 10.100.100.100, which is the tunnel destination, we have to use the physical route, which stands for 192.168.1.1. Okay. And finally, the loopback serves as a stable tunnel source and destination addresses. And the loopback, we use the loopback interface. As you can see, we have mentioned that the tunnel source is loopback 0 because a loopback interface is 100% stable interface and will become available as long as the router is up over the network. So this is it for the configuration part. Let's jump back to our misconfiguration of GRE tunnel. And we see that misconfiguration in GRE tunnel may lead to recursive route problem, which I already trying to understand you partially. And please go through the following scenarios, which may lead to tunnel bring down or a flip flap issue. So if a route points to an interface that it itself reach via a route, which is indirect next hop. And what type of misconfiguration is this? A route point to an interface that itself is reached via a route. For example, if we are not pointing the 10.100.100 route using a physical route, what will it do? In order to search for 100 and 100 route, it will look for routing table, it will check for the default route, and it slips to multiple hops. So it may be create an indirect next hop, and which may lead to tunnel flip flop, because sometimes the route may not be established and tunnel goes down. Next is tunnel or interface endpoint is reachable only via tunnel, which stands for circular dependency. So if we share a route that the 192.168.1.1, which is a physical interface route, will already be reachable inside the tunnel. So it will create a circular dependency, and will bring the tunnel up and down and up and down depending on the change of the interface status. Now, the redistribution of route that depend on the same protocol or path. Advertise what you learn. So if we already advertise the tunnel routes and external route to that another router, so the other router will use the physical interface in order to connect it, and this also leads to tunnel getting down. Now, advertising a loopback used as a next tunnel hop into routing domain. So this is kind of same thing that we advertise the loopback addresses to a routing protocol, for example, the OSPF or EIGRP or BGP. So what will it do? Because it establishes a direct route sharing between the BGP, it will also lead to the tunnel to be down. Now, asymmetric routing, where a return path uses a different route that references the original route. So if we are using a redundant type of connectivity in which multiple route exist in order to do the same thing, it may also lead to tunnel getting down. It's not always, but it may lead to. So we have to keep that in mind. So that the traffic always returns and comes back to the same particular interfaces. Okay, so we used to understand the load balancing and stuff, and we also have to take care of the tunnel. We can also use the route tagging and route maps in order to resolve the issue. There is some more issue that is listed, which is administrative distance. Yeah, metric ordering causes a selection of indirect path, missing or misordered route preference, VRF, routing instance, or policy misconfiguration. route summarization or aggregation of hiding the specific directly connected route. If we hide the specific connected route, for example, if we did not mention the route Ethernet FA0 in our example, it may also lead to uh, misconfiguration from our end, and it will lead to tunnel to be down. Now, next is route summarization or aggregation of a specific directly connected route. Proxy ARP or ARP table entry pointing to gateway that forward back to the router. So actually, you have to go through all of these on a Google search or a Chat GPT session one by one in order to understand the GRE misconfiguration. I think or I believe that I'm not able to help you understand all of these, because these things, and I am actually sharing you because these are the new things that I got to understand. And I may or may not have understood it completely on a different level, so I can tell you. So please take your time and go through all of this. I'm just a medium to share new things that you can learn. Okay. And finally, some prevention methods, which is do not redistribute the tunnel endpoint loopback into external protocol, is one of a prevention. Ensure route to remote endpoint exists without using the tunnel. We have already confirmed that the route of the fast ethernet 00 exists, and it able to ping or reach the second router D. And finally, apply the prefix filter or route map to block the loopback from advertise externally. So it is also a prevention method, and it is kind of first thing that either we did not redistribute the route, or we can use the prefix or route maps to block the loopback from advertising. Finally, administrative distance of a protocol can be changed using the command distance and administrative distance value, which ranges from 0 to 255 in a protocol configuration mode. And routing across a VPN tunnel is a legitimate for the GRE tunnel, else GRE tunnel creates unnecessary complexity. Uh, okay, so we are saying that routing across a VPN tunnel is a legitimate need for GRE tunnel, as GRE tunnel creates unnecessary complexity. So having a VPN tunnel side as GRE tunnel, we know that VPN provides encryption. It also offers a better way of managing the tunnels, because GRE tunnels itself creates complexity because it has too much of a requirement. It requires a physical interface, a loopback interface, multiple types of IPs, setting up sharing of domains, etc. So it's a very good thing. Finally, the protocol 47 is the IP protocol number assigned to a GRE. It identifies GRE as a payload carried inside an IP packet. So GRE also has a header. And in order to identify the header in a PCAP file, which is a packet capture file that we used using T-Shark or Wireshark, we can see if a protocol has a protocol number 47, then we can confirm that it's a GRE encapsulated packet. And finally, the IP header protocol field is 47. Yes, that is it. And IP header protocol field, which is the 8-bit protocol number, simply identifies the protocol type carried in the IP packet. So receiver knows which protocol handler to pass the payload. For example, if it's a 6, then it will be handled by TCP. If it's a 17, it will be handled by UDP. If it's a 47, again it's a GRE. And if it's a 1, then it's an ICMP message. Okay, finally, the PPTP, which stands for point-to-point tunneling protocol, uses GRE and port TCP port of 1723. So in case of using point-to-point tunneling protocol, for VPN, GRE needs to be allowed on firewall. So processing of GRE needs to be allowed because some routers may block it by default. And that's it for this video. Thank you for joining. Thank you for watching, and hope to see you in the next one.